Question 2 goes all the way back to the beginning of the chapter. It says a ball is dropped from a height of 1,500 centimeters and rebounds to a height of 750 centimeters. Complete the following questions. Part A says find the rebound ratio of the ball. And as we discussed in class, the rebound ratio is that value that we multiply the height that the ball was originally dropped from to approximate or to try and get or predict the height that it will rebound to. And it's nothing more than the height that the ball returns to, in this case 950, divided by the height that it was dropped from, which is 1,500. So this is the rebound ratio. And I think most of you took that number and you went ahead and turned it into a decimal approximation. So you can take 950 and divide it by 1,500. Whoops, I did not press divided by. And when I do that, I get this 0.63. So if you were to write 0.63 and you indicate that it does repeat, that's perfectly fine. The other thing is you answer questions as you perform operations. Use this entire decimal value. Keep it on the screen and don't round it off to 0.63. Another option would be just to investigate whether or not you can simplify this fraction. And sure enough, if I do take 950 and divide it by 950 and divide it by 1,600, or I'm sorry, 1,500. That does reduce to 19/30ths. So another way to write this is 19/30ths. So if I drop the ball again, you can see if I drop the ball from initial height of 1,500 and I multiply that by this rebound ratio, so I'll just hit multiply and I'll just grab it. There's the rebound ratio. When I do that, I get exactly 950. So the rebound ratio of the ball is 19/30ths, or 0.63 repeated, or 950 over 1,500. So it says find the rebound height after the second bounce. So I guess I'll go ahead and indicate that this is my answer for the first question. I'll put a box around this. And then it says find the rebound height after the second bounce. Well, I know it returns to 950 on the first bounce. So then to get the second bounce, I'm just going to come up and grab the 950. And then I'll just go back up and grab, so I'm hitting the up arrow, grab the 19/30ths again. And I need to multiply this. So I'm going to go ahead and multiply. And when I do that, I get 1805 over 3. Now, this doesn't happen often, but I would prefer a decimal value at this point. And because I've been dealing with fractions, my calculator is giving me answers with fractions. So similar to the way that I could kick a decimal into a fraction, if I want, I could press math, and then if I pick option 2, which is into a decimal, it'll take this previous answer on the stack, which is 1805 over 3, and it'll kick that into a decimal, which is 106, or I'm sorry, 601, and it's actually 601 and 2/3. So I'll go ahead and record this as 601 centimeters, and I'll just round this to 0.7. So one of the things is, like, when do I round, when do I don't round? Well, I like to keep all of my decimal values on the calculator display when I'm using them, but then when I write down a final answer like this, my rebound height on the second bounce is 601.7, I go ahead and round those down, round those to the nearest tenth in this case. C says find an equation that could represent the rebound heights. So again, this situation involves repeated multiplication. Every single time the ball bounces, I'm multiplying 19/30ths times the previous height. So because I have this repeated multiplication, the model that we use for this is a geometric sequence. So I could write and I could use it with y equals notation, or I could use t of n, but I'll go ahead and write that y, the height of the ball after each successive bounce, is equal to the 0th height, the height that it was before it was bounced at all. That's the original drop height, times my rebound ratio of 1930ths, and then raised to the x power. So for this, x is increased, the height that the ball returns to will become smaller and smaller. Now, because I've written it as y equal this way, it doesn't include the fact that this is actually a sequence, and that I wouldn't talk about the 1.3 bounce, right? I would talk about the first, the second, the third, the fourth bounce. So I could use my notation for a sequence and say t of n, the height of the ball after n bounces, is equal to 1500 times 1930ths raised to the nth power. Same exact situation, but by using this notation, I'm restricting my domain to just the ordinal numbers 1, 2, 3, 4, 5. And then the last question here says find the rebound height after the 10th bounce. Now, if I wanted to, I could just continue to multiply these numbers by the rebound ratio, and eventually I would get it, or I could use this model, this sequence that I have, and I'm going to choose to do that. So I'm going to enter my 1500, and I'm going to multiply that by and I'm going to go up to grab the rebound ratio again. I forgot where it's at. Here it is. And then I'm just going to raise that to the power of 10. So you can see here it's just 1500 times 1930ths to the 10th power. My calculator does something kind of nice for me. When I press enter, you can see that it's reading my mind, and it's inferring that I didn't want just the 19th to the 10th power, but the entire ratio of 1930ths raised to the 10th power. And it says after the 10th bounce, it should be at about 15 point, I'll round to the nearest 10th, 15.6 centimeters. So this is the rebound height after the 10th bounce. This is an equation that can model the height after each of successive bounces. So that's it for question number 2.